The Aldol and Claisen condensation reactions are important in organic synthesis because a carbon-carbon bond is formed. These reactions involve an enolate ion. An enolate ion is formed when a proton is removed from the carbon next to the carbonyl carbon, which is called the alpha carbon. The alpha carbon is the carbon adjacent to a carbonyl carbon. A proton bonded to this alpha carbon is acidic. When this proton is removed by a strong base, this conjugate base forms, and you can draw a resonance structure, which is the enolate ion. So stop the video and draw the structure of the enolate ion. So the enolate ion looks like this. Note that the enolate ion is a nucleophile, so an electrophile reacts with the enolate ion. Let's compare the acidity of some aldehydes, ketones, and esters. So stop the video and answer these 3 questions. So remember, the lower the pKa, the stronger the acid. So this compound is the strongest acid. And the proton on the alpha carbon for an ester is the weakest acid. The conjugate base of each compound looks like. And this compound is the strongest acid because this is the most stable conjugate base. You can draw several resonance structures of that base. So an enol is formed when an alkyne undergoes hydration. The enol undergoes proton transfer from the enolate ion. And we just looked at this reaction involving proton transfer of this proton bonded to the alpha carbon of an aldehyde or ketone. So let's practice. Stop the video and draw the structure of the enolate ion that forms when each compound is treated with sodium methoxide. So here are the structures. So remember to identify that alpha carbon, and then you'll be able to draw the enolate ion. The enolate ion is a nucleophile, and that enolate ion can react at a carbonyl carbon with an alkyl halide and with an acid. The Aldol condensation and Claisen condensation reactions involve an enolate ion reacting at a carbonyl carbon. Now, these reactions are important in organic synthesis because a new carbon-carbon bond forms, which allows big molecules to be made from small molecules. The Aldol condensation reaction is a nucleophilic addition reaction in which the enolate ion reacts at a carbonyl carbon. Note that a tetrahedral intermediate forms, which then goes on and forms a beta hydroxyketone, which then forms this alpha-beta unsaturated ketone. So stop the video and identify this reaction type. So this reaction type is an elimination reaction. So let's practice an aldol condensation reaction. This compound is treated with sodium hydroxide. Stop the video and draw the structure of the enolate ion, the tetrahedral intermediate, the beta hydroxyaldehyde, and finally the alpha-beta unsaturated aldehyde. So I hope you got these structures. So the enolate ion reacts to the carbonyl carbon to form the tetrahedral intermediate. Note that here is the alpha carbon and there is the beta carbon. Here is the beta hydroxyaldehyde or ketone. And the alpha-beta unsaturated ketone does not form because there's not a proton on this alpha carbon. So elimination cannot occur. A mixed aldol condensation reaction occurs when 2 aldehydes or ketones are treated with a base. So stop the video and draw the structure of the product of this reaction. If the proton from this alpha carbon is removed to form an enolate ion which reacts at this alpha carbon, the following product forms. If the proton from this alpha carbon is removed to form an enolate ion which reacts at this carbonyl carbon, this product is formed. I've shown the beta hydroxyaldehyde forming the alpha-beta unsaturated aldehyde. Collagen is a protein in the connective tissue of animals. So collagen undergoes oxidative deamination to convert the amine to an aldehyde, and then aldol condensation occurs. So stop the video and answer these questions. Is this collagen from young or old meat, and is this collagen from young or old meat? The smaller collagen molecules in young meat is softer and therefore more tender to eat than the bigger collagen molecules in old meat.